Good morning. How are you? So I want to go over the examples of how to solve problems 77 and 78 today. Um, on the board, I've written here problem number 77, and I've written down some of the given information. And some of it's a little problematic. We're going to have to work with it, but I want to walk you through how you should set up and solve these problems using the wave equation and the equation for the period. All right. So first of all, if you read the problem, it says water waves in a shallow dish are 6.0 centimeters long. 6.0 centimeters long. Waves in a dish are so long, right? This long. That's the wavelength. That's what this little symbol means. It's the Greek letter lambda. Lambda equals 6.0 centimeters. Now, we don't like centimeters. That's not the unit we want. We'll worry about that later. But that's the wavelength, all right? And then the next part's a little trickier, but again, the unit is key. The water moves up and down at a rate of 4.8 oscillations per second. Anytime they talk about something happening per second or per minute or per hour, they're talking about a frequency. They're talking about how often that thing happens. So if there are 4.8 oscillations or cycles or wiggles or waves, whatever it is, that's the frequency. So that's why we have F is 4.8, and the standard unit for frequency is hertz. Hz is the abbreviation for hertz. Okay? And the question is, what is the speed of the water waves and what is the period of the water waves? I'm going to put the book down. All right. We need to know the speed or the velocity and the period, t, of the water waves. We're going to do speed first, and we're going to recognize that v, the speed, the velocity, is equal to the frequency times the wavelength. That's the wave equation. Talked about that in the video the other day. The speed is equal to the frequency times the wavelength. So we need to convert this wavelength to the correct unit, which is meters. Centimeters is, there are 100 centimeters in a meter. So we have to divide this by 100 or move the decimal 2 places. We get 0.06 meters. Just like that is, like if that was this, right? If you see this, $0.06, that's 6 cents, right? Well, 0.06 meters is 6 centimeters, okay? So 0.06 meters. And again, it's frequency times wavelength, so velocity equals 4.8 times 0.06. And I need to get out my calculator. Here, 4.8 times 0.06 equals, and I get two significant digits. Actually, I should probably only, well, no, there should be two. All right, there are two there, so I'm going to have two in my answer. I get 0.29. And then the unit for speed, remember from first semester, is meters per second, 0.29 meters per second. So that's the answer to part A for the velocity. For the second question, it asks about the period. Now remember, frequency is how often something happens. This wave oscillates 4.8 times per second. So every second, it's going to go up and down or back and forth, whatever it's doing, 4.8 times. Period is the inverse of that. The period is how many seconds does it take to do it once? Or in other words, the equation for period is the inverse or reciprocal of the frequency. The period is always going to be 1 over the frequency. Well, in this case, that's easy because we know the frequency. So it's 1 divided by 4.8. So again, handy dandy calculator. 1 divided by 4.8 equals, and I get to two significant digits, 0.21 seconds. And period is a time. It's the time for one complete cycle. In this case, 0.21 seconds. All right. So that's how we calculate the speed and the period in problem number 77. Now, I want to move on to number 78. So I'm going to quickly erase all of this. I could have left that up there. But let me get the book and read the question. Problem number 78. Water waves in a lake travel 3.4 meters in 1.8 seconds. Ooh, can you tell what they're telling us there? 3.4 meters in 1.8 seconds. Meters per second. They're telling us the speed. They're telling us the speed in a weird way, but they're telling us the speed. So what they're telling us is that the speed is 3.4 meters in 1.8 seconds. If you remember first semester, distance over time. These waves are moving 3.4 meters in 1.8 seconds. So again, calculator, 3.4 divided by 1.8 is 1.9 meters per second. All right, so that's the speed of the wave. They've given us that in this problem. The period of oscillation is 1.1 seconds. So this time they're telling us that the period is 1.1 seconds. In other words, each wave wiggles or oscillates or cycles through in 1.1 seconds. In this problem, the questions are, what is the speed of the water waves and what is their wavelength? Well, we already calculated the speed. That's what we did here. V equals that. And we want to know the wavelength. All right, well, let's think about this. I already know the speed because I did distance over time. So that's 1.9 meters per second. I know the period. I want to know the wavelength. I know the wave equation tells me that velocity equals frequency times wavelength. So I can find the wavelength if I know the speed of the wave and its frequency. Now, what do I know? Do I know the speed of the wave? Yeah, I just found that out earlier here. But I don't know the frequency. But I do know the period. And I know that the period is equal to 1 over the frequency. And I know, because I know how to do algebra, that if the period is the 1 over the frequency, then frequency is 1 over the period. They're inverses of each other. Okay? So if period is 1 over the frequency, frequency is 1 over the period. So frequency is 1 divided by 1.1. Calculator. 1 divided by 1.1. And I get 0.91. 0.91 hertz. And then if I want to solve for wavelength, I divide both sides by frequency. So it's velocity over frequency. Okay. Wavelength is velocity over frequency. So it's 1.9 divided by 0.91. Calculate. 1.9 divided by 0.91. And I get 2.1. And it's a wavelength, so it's meters. So that's my answer. The wavelength of that wave is 2.1 meters. So, just to sum up, this is algebra, right? That's not new. We've been doing algebra to solve physics problems all year. The equations, maybe a little new. I think Mr. Dietz went over them with you at the beginning of his unit, and now you've read about them again in this new unit. But some of the terms, right? Frequency, the units, hertz, oscillations per second, wiggles per second, those are some new things. But again, if you're carefully reading the chapter, and if you are going through the videos that I'm posting up there, the terminology is going to start to make more sense to you. Okay? So on Monday, we're going to have a quiz. The quiz is going to be on the terminology and on using these equations. The wave equation, V equals F lambda, and the period or frequency equation, T equals 1 over F. You should know how to solve problems like 77, and sorry, this one is 78 that we just did. Okay? All right. Good luck, everybody. See ya. Have a great weekend.